Hi, my name is Lucas Kelly, and I'll be presenting to you a machine learning model that I've created that predicts Gold Glove Award winners with adaptive boosting. So the Gold Glove is awarded to two players from each position, one per league. That's the American League and the National League at the end of each season. And with players performing at such a high level, a large amount of advanced statistics are used to measure their fielding ability. And they take into factors such as ballparks that the players play in, and the different styles of play that the player might have. Players that, like Mike Trout here on the left, might have 0 errors, 271 putouts, and a fielding percentage of 100%. In the middle, you have Jackie Bradley Jr., who committed 5 errors in these are all from the 2018 season. He committed 5 errors, but he had more putouts, 299 putouts, and his fielding percentage was just slightly lower with those 5 errors. And then finally, you have Adam Engel with 7 errors, but the most putouts, 355 putouts, and a slightly lower fielding percentage given his 7 errors. Now, which player do you think should win this award? You have a player who committed 0 errors but didn't get as many outs, a player who committed 5 errors and didn't get as many, got much more outs, and a player who committed even more errors and got even more outs. This really shows that there are many more statistics to quantify and measure a player's ability in the field. And in this specific case, Jackie Bradley Jr. was the Gold Glove Award winner out of those 3 candidates. Each of these players were center fielders, but you can see that those 3 statistics are looked at in different ways. In this case, Jackie Bradley Jr. playing in Fenway Park in Boston has a much more difficult field to play in than his 2 candidates that were along with him in the voting. So this is what machine learning can do. It can utilize these advanced metrics, taking into consideration these adjusted metrics. New statistics are being created that better measure a player's ability, and this model will take into consideration these new highly advanced statistics that really have developed a different sense of player analysis. In addition, the model can improve over time. So at the end of each season, you can feed the model statistics from the season, and it can train itself on those measurements to better predict at the end of each season. So the methodology used in this project: first, data was gathered from Fangraph.com. It's one of baseball's leading sites. You can download CSVs directly from the site, pretty much catered to whatever sort of analysis you're doing. But I also used web scraping using Beautiful Soup to translate scraped HTML code into readable data that was combined with the data downloaded from Fangraph.com. The data that was scraped from baseballreference.com, and it was just scraping a table of previous Gold Glove Award winners. So these data frames were combined to give stats by player, by year, and whether or not they received the Gold Glove Award. So a 0 if they did not, and a 1 if they did, giving us our target column in our data frame. The data was then cleaned and explored a little bit, and was passed through a few different initial baseline models. K-nearest neighbor being one of them, a decision tree, a random forest, a tuned random forest, an adaptive boost, and a gradient boost. In addition, all of these models went through some form of hyperparameter tuning, PCA, a grid search to find the parameters that would best tune the model, and feature engineering to make sure that all of our features were allowing the model to predict accurately. In the end, the adaptive boosting ensemble method was the one that had the best predictive ability. And this model found an 89% accuracy score, 58% precision, 29% recall, and a 39% F1 score. This means really that the F1 score is a good metric to measure the model's ability overall. And though the lower the F1 score indicates that there's definitely some room for improvement in the model. In the end, the model performs well enough to accurately predict 4 players with Gold Glove Awards at the end of the 2018 season. The 2018 season was held out of the training data set to test the model's abilities in the end. And here were the findings from the 2018 season. So 4 of these players did actually receive the award. The ones that have the finalist tag were players that were predicted by the model to receive the award. In the end, they did not receive the award. However, they were finalists in the voting. 2 of these players did not receive the award. They were not finalists, but they are considered very good defensive players. And in the end, the model did inaccurately predict 9 players. It predicted that 9 of these players should receive a Gold Glove award, and they did not. However, that is not too terrible of a situation because it can really give a pool to voters, and then the voters can really pick through the data to decide which players should receive the Gold Glove. So if the model was over-predicting, it's really just giving voters a pool and really a group of finalists for the Gold Glove award. So how can this be improved? Well, I think something that needs to be investigated is the weight by position. The model seems to predict shortstops much more than it does any other position, and this could be due to the fact that shortstops are really likely to be involved in many more plays. Being in the infield and really the captain of the infield, they're much more likely to be involved in plays more than, let's say, a left fielder. It really needs to be finer tuned. The baseline out of boost model was really the one that predicted the best. There are a lot of techniques that can finer tune this model to improve its predictability. I would love to experiment with the XG boost algorithm. This is a new algorithm that has a lot of predictive ability and a lot of power. And I'd really be interested to see how well that algorithm, how it can improve this model. And then finally, I plan to test the model in the upcoming 2019 season. So when the season ends, I'll pass through all the fielding statistics into the model and see how accurately it can predict the winners. And here's my portfolio page and my GitHub, in case anyone would like to see the notebook and the tools I used to create this model. Thank you very much.